The product and quotient rules are two rules that help us take derivatives of more complicated expressions than we've seen in the past. Here's the idea. How do we do something like this? How do we find the derivative with respect to x of one function times another function? Well, unfortunately, it's just not take the derivative of each one of them. You actually have to do this. It's going to be the derivative of one of them times the other plus the other way around, the derivative of the first times the second. All right, so the idea here is anytime you're taking the derivative of functions joined by multiplication, you take the derivative of one function at a time and multiply by the other, plus, and then the other way around. Now, generally the way that I have students memorize this, make it a little bit easier. Instead of saying f and g, let's call these functions u and v. Now, u here is still a function of x and v is still a function of x. I'm just simplifying the notation. So if we were to write it like this, this would be u prime v plus v prime u. So all we'd have to do is state which function we want to call u, which function we want to call v, and then just plug it in here. The second one, which is also another formula that we need to know, what if we take the derivative of one function divided by another function? Well, this one's a little bit more complicated. This will be f prime times g of x minus f of x times g prime of x, all divided by g of x squared. So the formula is a little bit more complicated, but let's go ahead and look at it with the u's and v's, and you're going to see why I want you to memorize it like this. So this would be u divided by v. This will be u prime v minus v prime u all over v squared. So if you remember the product rule like this, remember the top of the quotient rule is exactly the same except for it has a minus, and of course you have to take the derivative of the top first, and all over whatever the denominator was squared. So it is just a couple of rules here. Don't let it throw you off. They're not too bad to do. So let's start out with this. Just find the derivative. So there's our directions. Let's start with just the first one about f of x is equal to 2x plus 3 for x minus 5. All right, there's a little bit of good news and bad news in this section. The good news is technically at this stage of this course, we really don't need the product rule that much. By the way, in case I didn't write it, this is our product rule. And this was our quotient rule. Sorry, I didn't write that down. We really don't need these because there's another way that we could do it. This one might have been in the homework section from the previous section on the power rule, because all we'd have to do to use the power rule would be to distribute everything out, combine like terms, then we could use our power rule. But let's take a look how this is going to work using our product rule here for this, because we have two functions of x multiplied together. Here's how I would suggest you doing it until you get good at it. Let's call one function u, the other function v, kind of like that. And then underneath here, let's go u is equal to 2x plus 3, v is equal to 4x minus 5. Now for our formula, remember we're doing our product rule here, we need u prime and v prime, so that's easy enough. Just take the derivative of each one of these and we can use our power rule. So the derivative of 2x is 2, the derivative of 3 is 0, the derivative of 4x is 4, and the derivative of negative 5 is 0. Now all we're doing is plugging into our rule. U prime v plus v prime u. Say it 100 times before you go to bed tonight. So the derivative, f prime of x, of the original function, is going to be u prime, 2, times 4x minus 5, plus v prime is 4 times 2x plus 3. So u prime v plus v prime u. Now at this stage, the author is going to try to simplify this, and I'm going to show you. So let's go ahead and distribute. It gives me 8x minus 10 plus 8x plus 12, or 16x plus 2. Okay, so there's our derivative. Now for this one example, I'm going to show you that we could have done this using older methods. Again, we're trying to learn this for stuff that we're going to need later on this semester. So what would have happened if I would have taken this original expression and distributed it out? Well, that would have been 8x squared minus 10x plus 12x minus 15. Or our original function would have been 8x squared plus 2x minus 15. Now that I've rewritten this so I can see every term with just x to a power, I can now find the derivative of this using our power rule. So that would be bring down the power, so that's 16x plus 2. Notice, of course, it's the exact same answer. So at this stage, we actually have two different ways that we could do it. We could go ahead and distribute it out and take the derivative. But here in tonight's homework, we really want to be practicing the product rule. Like I said, we're going to need it in the future. So let's try one more of these product rules to kind of see how it works. I'll leave it up there a second. So let's say that we have y is equal to square root of x times x squared minus 4. Okay, now if we're told to find the derivative here, we know we can't just use our power rule because we still have things joined by multiplication. We just don't have it as every single term is x to a power. So what we're going to want to do is, let's say, okay, we have two functions here. Let's call this u and v. So I'm going to go down here, I'm going to say u is equal to, now I know I need to take the derivative, so I'm going to write any radicals as fractional exponents. V is x squared minus 4. So u prime, bring down the power, take one away from the power, and v prime, bring down the power, take one away from the power. Now again, our good news here is now that we have all the pieces, all we need to know is our rule, which is u prime v plus v prime u. And plug it in. So our derivative, our function was y, so let's use our Leibniz notation or differential notation. So dy dx, or y prime, is equal to u prime 1/2 x to the negative 1/2 times v, that's x squared minus 4, plus v prime is 2x times x to the 1/2. All right, so u prime times v plus v prime times u. Now from this stage, you may have to do some algebra to get it into the form that the author has as answer. So I'm actually going to leave it right there for now. See if you can try to simplify that the best that you can. You're going to be doing a lot of that in the homework. All right, that is the product rule. Again, very straightforward. You just, anytime you have two functions multiplied together, call one u, call one v, take the derivative of each one of them, plug it into your formula, and then the hardest part, like always in calculus, is the algebra to try to simplify the expression. All right, let's take a look at when we might want to or might have to use the quotient rule. Okay, again, let's start out with some function. Let's say it is 2x plus 3 over x plus 5. All right, at this stage right here, there's really no way that we could rewrite this expression, so we could just have a bunch of terms with x to powers and use our power rule. So for this, we actually need to do the quotient rule. So for the quotient rule, the idea is here we're dividing two different functions of x, called the top function u and the bottom function v. Now for the product rule, since we have a plus here, it doesn't matter which one you call u and v, but for the quotient rule, since there's a minus sign on the top, u has to be the top function. So when you're labeling them, u is always the top. So exactly like we just did before, I'm going to say u is 2x plus 3, v is x plus 5. Take the derivative of each one of these, u prime would be 2, v prime is just 1. And then write down your quotient rule. U prime v minus v prime u all over v squared. Now that we have all the pieces, all we got to do is plug the pieces into our formula. So u prime is, oh, by the way, our function is g, so our derivative g prime of x. So u prime would be 2 times v is x plus 5 minus v prime is 1 times u would be 2x plus 3, all divided by v, whatever the denominator is, squared. All right, so there we go. We found our first derivative. Again, simplification is going to happen after this. This one's pretty quick and easy, so I'm going to go ahead and do this. I'm going to distribute everything out on the top. So let's see, g prime of x would be, when we distribute, that's 2x plus 10 minus 2x minus 3. We distributed to negative 1 all over x plus 5 squared. Or g prime of x would be, let's see, the two x's are going to reduce, so we have 7 over x plus 5 squared. All right, so that's simplified quite a bit. Okay, so there is the derivative using the quotient rule. Again, called the top u, the bottom v. Write it out just like we normally do. Plug it into your formula and then simplify. Quick hint, you generally don't want to distribute out the bottom. Just go ahead and leave it like it is. Let's try one more of these. I'm actually going to let you try one here. So same idea. Let's say, I don't know, y is equal to x squared plus 3x minus 4 all over 2x cubed minus 5. So a little bit harder. Do me a favor, see if you can figure out what u and v are, take the derivatives, plug it into the formula, but don't simplify. We'll simplify together. So go ahead and find the derivative for me, please. All right, if you're back, let's see how we did. If you're not back, you can't hear me. All right, so again, we're going to let the top be our u, the bottom be the v. So we're going to say we're going to let u be x squared plus 3x minus 4. V is equal to 2x cubed minus 5. U prime, taking the derivative of this, just using our power rule, gives us 2x plus 3. V prime, again, using our power rule, would just be 6x squared. Remember, power rule, bring down the power, take one away from the power. Writing down our quotient rule, u prime v minus v prime u all over v squared. So here we go, we got y prime, or again, let's go ahead so we get used to seeing both notations. dy dx, again, if you put y prime there, it's perfectly fine. U prime is 2x plus 3 times v is 2x cubed minus 5 minus v prime 6x squared times u, is all this, x squared plus 3x minus 4. All right, did I get that right? All right, all over, big giant mess, v, which was 2x cubed minus 5 squared. Okay, so this is the stage that you should have gotten to. So if you made it here, great job. I'm going to keep going. I'm going to go ahead and distribute everything out on the top and see if I can combine some like terms. So dy dx, or y prime, whichever notation that you use, dy dx, when I distribute on the top, that gives me 4x to the fourth. Times that. 2x times negative 5 is negative 10x. 3 times this gives me 6x cubed. And then negative 15. Minus, we're going to take this 6x squared and distribute. That gives me 6x to the fourth. Minus 18x cubed, run out of room, plus 24x squared. Okay, hopefully you guys can see all those. All divided by, the denominator didn't change, that's 2x cubed minus 5 squared. All right, so let's combine some like terms on the top. So dy dx, let's see, we do have some fourths. 4x to the fourth minus 6x to the fourth is negative 2x to the fourth. I got some cubes. 6x cubed minus 18x cubed is negative 12x cubed. I do have some x squared, so that's plus 24x squared. I have some x's, minus 10x and minus 15. Ugly. All over 2x cubed minus 5 squared. All right, so there we go. I don't see a way to simplify that any further, so that is our derivative of the original. Remember, anytime you see a fraction, you're thinking quotient rule. So derivative of the top and the derivative of the bottom. put it into your formula and simplify. For these, most of the time, simplifying is going to involve just distributing out the top and combining like terms. Occasionally, you're going to have to factor out the greatest common factor. All right. So one application when you might see the quotient rule come into play has to do with three things we generally see in business. We have a cost function, we have a revenue function. I'm just using the letters most textbooks use here, and then we have a profit function. All right, these are the three big topics that you always are interested in business. Now, of course, the cost function is the entire cost to, oh, by the way, real quick, your X is the items or units produced or whatever they are. So here, X can be, if you run a bicycle company, it may be bicycles. If you're selling cars, it might be cars, it might be computers or cats or whatever you're selling basically is what X is. It's whatever those things are. The cost is any cost associated with running your company. So that could be the rent and everything else all piled into one function. Revenue is the total amount of money that you bring into your company. So, you know, all your sales, everything you bring in. Now, of course, profit, in case y'all haven't seen this before, profit is going to be your revenue minus your cost. Now, of course, you want this to be a positive value or you're not making any money. But if you ever want to find the profit function is always equal to the revenue function minus the cost function. These are just some basic ideas here. One of the things that you will talk about in a business type course is the average cost or the average revenue or the average profit if you sell so many items. See, it's kind of weird that people think if you're in a company, let's say that you're making bicycles, it actually costs a lot more to make the first bicycle that you make than the 100th bicycle that you make. The price actually goes down because you have infrastructure in place, all the overhead is spread over, you know, the number of products that you do. So one of the things that you may be interested in is the average. Try that again. I'm going to just call this the average function. So here, if I wanted the average cost, the average revenue, or the average profit, all you're going to do is just divide each one of these by how many items that you have produced or sold or whatever it is. So the average cost will be the cost function divided by X. The average revenue is the revenue function divided by X. And the average profit, of course, would be the profit divided by X. Now that's the average for the number of items that you have sold. So notice here why this would come into play in this section. Here we're automatically making a fraction, which means when you're taking the derivative of the average cost, a lot of times you're going to be using the quotient rule. So see how the homework plays out this? These are just kind of definitions for you. A little bit later on, we'll take a look at some more business type applications.